All right, also, I wanted to talk briefly about how the human eye works now, because I think this is an important thing for you guys to see and to understand. Because our eyes actually are, and they do involve and have these lenses in them, right? So within our eye, right, so you have, if we look at our eye, right, you got like kind of the white part. I'm not actually sure what that part's called. In any case, you got like the iris, and then you have the little pupil. And the pupil is the part that we're actually concerned with because that is the hole through which light actually enters. So if you guys remember when we made our camera obscuras, we had a dark box, dark room, and we poke a little tiny hole in it, and that lets a little rays of light in. And if the hole is very small, then it only allows them to kind of come in at a specific angle, and they strike the surface on the back of the box and create an image, right? A real image. There are actually light rays that are striking and converging at that point. Now, with your eye, it's kind of similar. Your pupil is kind of like that hole. However, if you remember with camera obscura, if we made a big hole, we got a really fuzzy image. So how is it that we can get a really sharp image with our eyes? Well, in that little hole, right, we actually have a lens. We've got a convex lens, right? So it's a converging lens that actually brings rays of light that are coming in and converges them, right, and focuses them to the back of the retina, right? So this black area is kind of the retina. This little black line represents where the retina is. That's where those cone and those rod cells are that can actually pick up those light waves and sense that we're actually seeing light there or seeing an image, a real image. Now you'll notice here, if we have like a tree in the distance, right, we've got our lens here in our eye, and it flips that image, right, and it creates an upside down image that is very real, right? So there are actually rays of light converging at that point, and that's how we can pick it up. But it's a flipped image, right? So one thing that is interesting about how our eye actually works is that as that signal, right, from those cones, that there's light striking that point, as that is sent to our brain, somehow, and we don't really fully understand how this works, but somehow our brain actually flips that image right side up, which is why we don't see the world upside down, but we actually see it right side up, even though the image that's actually striking the back of our eye is an upside down image of reality, right? So it's kind of crazy. Now you'll notice one other thing with this is that there's this spot here in the back of the eye where the optic nerve kind of connects to those cone and rod cells, right? So that's where those nerve and signal impulses are sent to the brain. It's through this optic nerve. Now you'll notice right around that optic nerve there's no retina, right? There's no rod or cone cells there. So there's actually a point where if an image is focused on that point there in your eye, you cannot perceive it, right? Which we'll talk about in a second. So what's important to know here for how our eyes work, right? So within our eyes, there is a lens, a double convex lens that focuses light on the back onto our retina, right? The image this lens creates is real, smaller, and upside down, right? Our brain receives impulses from our rod and cone cells via the optic nerve that tell us that light is striking that particular spot. Right, so that's what actually allows us to see. So it's similar to like what we talked about when we were mentioning color, right? Certain wavelengths are coming in through our eye, through our lens, and actually strike those spots that allow us to see that things are those colors. And then our brain kind of perceives that, interprets it. Now, like we said, one thing our brain has to do is it has to interpret what those colors are and allows us to see that. It also flips the image upside down. So there's a lot of kind of fascinating stuff besides just physics, besides just biology, getting into like psychology, that allow us to see and perceive the world around us. It's actually a very complicated thing. It's kind of cool. But this is one of the key things, is that we have this lens that allows us to see this relatively focused, crisp view of the world around us. Now, going to this blind spot, this is actually kind of a cool thing that I want you guys to try. So here I have, as I mentioned, there's that spot where your optic nerve in the back of your retina, where there are no rod and cone cells, so you can't actually pick up things. So what I'd like you guys to do here is I have this this plus sign and this dot. One's on the left and one's on the right. I'd like you to go ahead and cover your right eye, so you're only looking with your left eye, and I want you to look at that circle, at that black dot, right? And what you'll notice is if you kind of like move in or out, right, there will come a spot where if you're just staring at that black dot, right, there'll come a spot where that plus sign will actually disappear. And when that plus sign disappears, that is the point on your left eye where the light coming from that plus sign is actually striking, right? If your eye is looking at that black dot, the light that is coming into your eye from that plus sign is actually being focused onto where your optic nerve is, and there's actually a blind spot. You can't see it, right? Now, when you're looking with both your eyes, this doesn't happen because your eyes, since they're offset, right, they can pick up, one eye can pick up what the other can't see because that plus sign would actually be focusing on a different spot on my right eye, so I can actually see it. But if I just cover one eye and just look at that black dot, you'll see there's a spot where the plus sign disappears. The same can be true if you close your left eye and you look at the dot, right? There'll come a point, and you move your head in and out, there'll come a point where that black dot actually disappears, right? That is where that black dot, the light from that black dot, is being focused on that blind spot in your retina, and you can't actually see it. Now, your brain has a lot of tricks to kind of go around this. Like I said, you have the two eyes that'll kind of help this not be too big of a problem, and your brain can do some funny stuff with filling in what is surrounding there. So right now you see it as just not being there, and you see it as a white background, not because there actually is a white background, but because your brain is filling in that there is white there. So if I actually replace this with some colored backgrounds, and we do the same thing, right? Cover your right eye and you look at the dot and you kind of zoom to the point where the plus sign disappears, you'll see your brain is actually filling it in with green, with a green space, right? So it's kind of cool how our brains actually perceive and kind of create this world around us that we see, right? Which is very much a real world as being perceived, right? These light rays are entering our eyes, are being picked up by those cone rod cells on the retina. But then it's all interpreted through our brain, which is kind of cool. Now, a few common things, a few other cool things about our eyes. Number one is that our eyes, you'll notice, right, the lenses, depending on how far away something is, a lens is better or worse at focusing things. If you take like a magnifying glass, for example, and you bring it like too close, everything becomes kind of out of focus. But if you bring it to a certain distance, right, things become more crisp and more in focus. So by changing the shape and the size of that lens, we can make it so we can focus and see things so they're projected properly onto our retina. So if we have an object that's really far away at like infinity, right, so far away that these light rays coming in are almost in parallel, right, we don't need to bend those light rays as much to create a crisp image, to focus that image on the back of our retina. So what we do is we have these muscles, right, that attach to our lens, right, those muscles are kind of contained within our iris, and those muscles, right, they can pull on the lens to make it thinner, right, or they can relax, in which case the lens is thicker. So when we don't need to bend light rays as much when we're looking at objects that are far away, right, those muscles contract, they pull on that lens so that it's thinner, it doesn't bend the light rays as much. Whereas if we're looking at objects that's closer, so those light rays are coming in at more of an angle, and we need to bend the light rays more, then those muscles relax, the lens is thicker, and it bends those light rays more to allow it to still focus. So this is pretty cool. So we actually have muscles that attach to our lens in our eye and allow us to change the shape of our lens so that we can focus light in just the right way, right? And so that's actually a pretty cool thing. Now there's a few things that can go wrong with all of this, right? So I don't know how many of you guys know that there's a few of you in there who definitely wear glasses and or contacts, some kind of a corrective lens, right? So I personally wear glasses and contacts, and I have a hard time seeing things that are far away, right? Now I always forget about this, but I believe that means that I am nearsighted. I can see things that are near, right, that are close by without corrective lenses, but when things get farther away, I can't see them. Now other people can be farsighted, right? They can see things that are far, but they can't see things that are close as well without corrective lenses. This can be caused by a few things. It can be caused by defects in your lens shape, right? So it's not the right shape so that your eye can't kind of focus things correctly. It can also be caused by the eye being too long or too short, also making it so it becomes hard to focus either when things are too far or too close, right? So how can we actually kind of fix these using corrective lenses? So how can my glasses, for example, right? How can my glasses actually fix my nearsightedness, right? Well, in my case, it's because the light rays are being focused at a point that is too far away from my retina, right? So by the time that they're focused, they actually spread out again, and the object appears kind of blurry, right? Now this is relatively slight, but it's enough that it can cause some serious problems. And so what happens is we actually put a concave lens, right, a diverging lens. It makes it so that these light rays, right, from when they hit my lens, they don't converge quite as quickly because they've diverged a little bit first because of this concave lens. And so then it strikes the retina in just the right spot, right? So what I can do is this, and you can kind of tell just by looking at it, my image is smaller, right? It's right side up, so that tells you that this is a concave lens. So my glasses, right, help with this problem. Okay, so one thing that we can do is if light is focusing in front of the retina, then we can use a concave or diverging lens to make the focus farther back in the eye, right? And so that's how this works. And then similarly, let's say that you're farsighted and you have a hard time seeing things that are close up. What that means is that your lens is not quite strong enough, right? And so you are focusing light on a point that's too far away. It's behind your retina, so it appears fuzzy when it actually strikes your retina. Well, we can use a convex lens, right, to help focus that light a little bit more, so that it hits the retina in just the right spot. And so that's if you look at this, right? These are like my mom's reading glasses, because she has a hard time seeing those things that are close up, and you'll see that they kind of make my eye bigger and right side up when they're close. And if you look at things that are farther away, let's see if we can get it, but they can cause things to be upside down, right, from farther distances, and smaller, right? So this is a classic kind of convex lens in these glasses. And so if light is focusing in behind the retina, we can use a convex or converging lens to focus the light sooner, right? So it hits the retina in focus, right? And that's that. So that's how we get these two different kinds of glasses. The same is true with contacts, to just kind of a much smaller, finer scale right there on top of the eye. But it's really just kind of slightly modifying the shape of this lens so that it focuses light in the right spot, so it hits the back of our retina. So that's a little bit how our eyes work. Hope you guys kind of learned something there. And then last, I just kind of want you guys to check out this last part. It's just kind of fun. More talk about death rays, right? This time using lenses instead of mirrors. So it's kind of cool stuff. But yeah, so lenses are pretty awesome. I hope you guys kind of learned a decent bit there. Hopefully you guys feel good with these kind of topics that we're trying to get you guys to learn. And yeah, I'll see you guys next time.